I am Vaishali Shah from LJ Institute of Engineering and Technology. In our subject called Fluid Mechanics and Hydraulics, today we will start our new chapter, which is Total Pressure and Center of Pressure. Okay. In last lectures, we studied Pascal's law, manometers, types of manometers, and examples based on manometer. Now we will start a new chapter. But remember that here also there is a fluid static. So fluid is in rest condition. So let's start with our first of definition, which is total pressure and center of pressure. First of all, what do you mean by the total pressure? So the total pressure is defined as force by what? Force by static fluid on surface, either plane or curved, when the fluid comes in the contact with the surface. You can clearly understand by this diagram. Here you can see a block which is immersed or emerging in the fluid. A glass filled up with water. This rectangular block is emerging in the fluid. Now, the total pressure is forced by this fluid. As you can see, the fluid in the glass is in steady condition, which means it is in fluid static. So the fluid in the glass applies some kind of force on this cube, on this rectangle cube, when it comes into contact with this fluid. So that force is called total pressure. Force by static fluid. Force by this steady fluid on the surface, either curved or plane. So this total force by static fluid is called total pressure. Okay. Now our second definition is center of pressure. So center of pressure, the point at which the total pressure is acting. As if you know that, what is center of gravity? Yes. Center of gravity is that point from where mass of the whole body is acting. Weight of the whole body is acting. So that point is called center of gravity. Likewise, the total pressure is acting from some particular point. So that particular point is called center of pressure. As you can see in this diagram, there is total pressure force acting on this cube. Now total pressure force is acting from some particular point, then that point is called center of pressure. Okay. So in this chapter, in this whole chapter, we are going to study total pressure and center of pressure for different body shapes like rectangle, triangle, circular, hollow circle, trapezoidal, etc. Okay. So in this chapter, you are going to study total pressure and center of pressure when a body, like this body, when the body is immersed in static fluid. The fluid is in steady condition here. Okay. So let's start with our first theory, and the title of our theory is Vertical Plane Surface Submerged in the Liquid. Now, as the title of this theory indicates that the immersion surface is vertical here. The surface is immersed vertically in the liquid. Okay. So for that, we are considering a plane surface of arbitrary shape immersed in the liquid as shown in figure. Like this is your vertically immersed surface. Arbitrary or random shaped surface. Okay. Now, some important points in this diagram. As you can see, there are 2 points at center. First, G, and second is P. G and P. G is called center of gravity and P point is called center of pressure. From point G, total weight of the body is acting, and from point P, total pressure is your arbitrary shaped surface, and now above is your free surface of the liquid. This is your free surface of the liquid. Now there are 2 points, center of gravity and center of pressure. Remember that for the submerged body or immersed body, center of pressure is always below center of the gravity. Okay. Now we are considering free surface of the liquid here. Now from the free surface, distance of center of gravity is what you can see, h bar. From free surface of the liquid, distance of center of gravity, that is h bar. Now from free surface of the liquid, the distance of center of pressure, P point, is indicated as h star. You can clearly see that in figure. H bar is the distance of free surface to center of gravity, and h star is the distance between free surface to center of pressure. Okay. Now here we are considering a small strip. As you can see, here we are considering a small strip. So here we are considering a small strip of width d, and the distance between strip to free surface of the liquid is small h. So here there are 3 distances, h, h bar and h star. Width of the strip is b. Width of strip is b, and depth of single strip is dh. Depth of single strip is d into dh. Clear? Any doubts? Let's start. Again, this is diagram of your immersed body, where capital A is area of the surface, area of the total surface. H bar, distance of CG. CG is your center of gravity, the area from free surface of the liquid. G is your center of gravity. Now P is the center of pressure here, and H star, that is the distance of center of pressure from free surface of the liquid. Now, first of all, we have to find out total pressure force. Total pressure force acting on the immersed body. This is your body, and we have to find out total pressure force acting on this body. Okay. So total pressure force we indicate as F. Now, the total pressure force on the surface may be determined by dividing the entire surface into number of small strips. We are considering the whole surface. Now, divide this surface into number of equal strips, then you can find out total pressure force. How? Let's see. Now, we are considering a strip here. Thickness of this strip is dh. As we discussed earlier, that thickness of this strip is dh, width of this strip is d, and depth from free surface is small h. Now, this is your strip that we are considering here, indicated with that red color. Now, pressure intensity on this strip. First of all, we have to find out pressure intensity on this single strip. Then we know the equation for pressure, P equals to rho G H. So pressure intensity on single strip, P equals to rho G H. Okay, where rho is the density of fluid, G acceleration due to gravity, and H, that is the distance from free surface. So first, now we can find out area of this strip. As we know that area of this strip, we are taking as dA, and area, that is width into height. Width of this strip is d, and depth of this strip is dh. So area of strip is dA. So dA equals to P into dh. Okay. Now we will find out total pressure on this strip, which is indicated as dF. So total pressure on this strip dF, as we know that force equals equals to pressure into area. Pressure into area. So pressure is your P and area, that is your P, is rho into G into H into B into dH. So this is your equation for P and this equation is for dA. So total pressure force on strip is equals to P into dA. E into dA. Okay. We have both the equation for P and dA. So place that equation here. Here. Total pressure force on whole surface. Here we found pressure force on single strip, which is dF. Now we have to find out total pressure force for entire body. Then you can find out by integrating force on single strip. Total pressure force can be found by integrating force on single strip. So you can take F, total pressure force, equals to integration of dF. We know the equation for F, which is P into dA. So integration rho G H into D into dH. Now here rho and G are the constants. So integration B into H into dH. Here integration B into H into dA. Okay. What is D? Width. Okay. So width and what is dH? That is height. Width into height. You can replace by area. B into dH is your area. So you can say that integration B into dH equals to dH. So your step becomes integration H into D. Integration H into dH. Now, integration H and dA, H into dA is the moment surface about free surface of the liquid. What is integration H dA? That is moment of surface. Movement of surface about free surface of the liquid, where equation for this movement is area of the surface and distance from the CG. Area of the surface into distance CG from free surface. Okay. So here you can replace integration H into dA by A into H bar. A into H bar. Remember this step, integration H into dA, that is moment about free surface, which can be replaced by A into H bar. So if you are placing the value of integration H dA in above equation, then you get F equals to rho G H bar into A. Rho G H bar into A, where rho is mass density of the liquid. G is acceleration due to gravity. H bar, what is H bar? Distance of CG from free surface of the liquid. So H bar is distance of CG from free surface of the liquid. And capital A, that is area of the body. So we find the equation for total pressure force F equals to rho G H bar into A. Now we have to find out, this is your equation number 1. Now we have to find out center of pressure, which is location of center of pressure, which is H star. As we know that P from the free surface, distance between P and free surface is H star. So second step we have to find out H star. So let's start. This is your diagram for a body which is immersed in a liquid. The resultant force F, as we know that resultant force F, which is rho G H bar into A, acting at point P. Total pressure force is acting from center of pressure. So total pressure force is F here, and F is acting from point P, which is at distance H star from free surface of the liquid. Okay. So moment of F about movement. Moment of total force F. Now total force is F at a distance x star. So that moment is F into x star. Okay. Total pressure force F and distance is h star. Now, sorry. This is your equation number 2. Now, the moment of dF. If we have to find out force on single strip, then it is dF, and the distance of single strip from free surface, that is h. If we are finding out moment of single strip about free surface of the liquid, then what is the equation for moment? Force into perpendicular distance. Force on single strip is dF, and perpendicular distance is small h. So your moment of single strip about free surface is dF into h. So we know the equation for dF, which is rho g h into d into dh into h. Clear? So we know dF equals to rho g h d into dh. We derived in our earlier steps. Okay. Now we know the equation for F, which is rho gh into d into dh into h. Now summation of moment of all forces about free surface of the liquid. Summation of the moment. Then you have to integrate the moment of single strip. So you can find out summation of the moment. So by taking integration rho g h into b into dh into h. So b into dh, b width, dh is depth. So b into dh is dA, area of the strip. So here integration, next step is rho into g, that is your constant, rho g integration dx square into dh. Now integration x square into dA, integration x square into dA, that is integration dx square into dh is second moment of inertia about free surface of the liquid. You will study the moment of inertia concept in your subject called mechanics of solid, and we applied that concept directly in your subject fluid mechanics and hydraulics. So integration of h square dA, that is b into x square into dA, is second moment of inertia, which can be written as I0. I0 is your second moment of inertia. Now, sum of moment about free surface, that is rho g integration x square into dA, which is rho g I0. Rho into g I0. I0 is your second moment of inertia. Clear? Now, this equation is your equation number 3. Equation number 3. Now, equating equation 2 and 3, we get, this is your equation number 2, which is F into H star equals to 2. And this is your equation number 3, rho g I0. Now, equating both the equation, F into H star equals to rho g I0. So, F, we know the equation for F, rho g h bar into A. So, rho g h bar into A into H star equals to rho g I0. By simplifying this equation and making H star as your subject, you get H star equals to I0 upon AH bar. I0 upon AH bar. Now, this is your equation number 4. But by parallel axis theorem, you also study this parallel axis theorem in your subject called MOS. By parallel axis theorem, you can replace I0 with Ij plus AH bar square. This is the final formula for parallel axis theorem. And by parallel axis theorem, you can replace I0 by Ig plus Ah bar square. So I0 equals to Ig plus Ah bar square. By replacing in your equation number 4, this is your equation number 4, I0 upon Ah bar. So I0, which is Ig plus Ah bar square, divided by Ah bar. So H star is Ig upon Ah bar plus H bar, where H star is distance of free surface to center of pressure. Distance between free surface to center of pressure. Ig, that is moment of inertia. Capital A, that is area of the body. H bar, that is center of gravity to distance between free surface. So this is your final equation to find out location of center of pressure. So in this theory we derive two equations. First is for total pressure force, which is F. F equals to rho G H bar into A. And second equation is for total pressure force. So to find out location of total pressure, which is H star, and H star equals to Ig upon Ah bar plus H. Now in our next lecture, we will solve some examples based on this theory, vertical and vertical surface. Okay, thank you.